We're going to start talking about pointers and addresses and how they work together. This is not really a complicated subject, but it can get a little confusing. So I'm going to say these things a few different ways. Hopefully it won't be boring, but you will notice some repetition in this video as we talk about this, because I really want you to get a good feel for what's going on here. Memory in your computer, if you haven't thought about it, is divided up into the smallest units of computer storage, and those are bytes. Bytes are made up of bits, which is short for binary digit. If you've been around programming for a while, you probably already know that, but it bears repeating. So there's a number of bits in a byte. In the systems that we normally work on, in 32-bit systems that run Windows and normal Linux, that sort of thing, that are not 64-bit machines, a byte is the smallest value that we work with, consisting of 8 bits. 4 bits, we call them the high and low order sets of bits, are called nibbles. Actually, they are. They're half a byte, so it's a nibble. I always wondered myself if 2 bits were a lick, but that's a whole other subject. Anyway, memory is divided up into 1-byte pieces. Every one of those individual bytes has an address. It has a physical location in the computer. Now, the way I choose to show you addresses in this is with a base and an offset. I use the base of 1, 2, 3, 4 just for conversation, and an offset starting at 0. And in this case, we run up to B. I'm doing hexadecimal here. Hopefully you know a little bit about hex. It goes 0 through 9. A is 10, B is 11, and it goes all the way up to F for 15. And then if this digit were a 1, that would be 16. So 1, 0 is decimal 16, 1, 1 is 17, 1, 2 is 18, and so on. But anyway, that's the way I show these addresses, and that's the way you'll see them commonly if you're looking through listings, that sort of thing. So that's how this is laid out. A pointer, because we're talking about pointers and addresses, a pointer contains the address of a single byte of memory. Just like your house address. If your house address is 1234 Main Street, that is a pointer to the address where all of your stuff is located. So here we see this is an address of this H in Hello World. This is our string. Hello World, that's a space in there, and that's a null, a 0 byte, that is the end of our string. So we have our little string laid out here. If this were an array, and we're going to see more of that, then these are the elements of the array, 4, 5, 6, 7. 0 is the first element of the array, base 0, and then that's our piece of memory. Now this 0 has nothing to do with that 0. I just happen to say that this piece of memory is starting at this base and offset of 0. This number could be any old thing, anywhere throughout the memory of our machine that is available to our program. So a pointer, when it is created, will contain one of these addresses. That's what goes in a pointer. And a pointer is always large enough to contain a single address value from within your computer. And those lengths of pointers will change based on the kind of hardware that you're running on. All right, so memory is divided up into 1-byte pieces. They all have their own address. When we create a pointer, a special kind of variable, we are creating a variable that is big enough to hold the address of a single byte of memory.